Welcome to Shanti-Peace for Mathematics. In this video, we're going to discuss regarding a successive derivative of rational functions, or I can say nth derivative of a rational function. So first of all, one should know what you mean by a rational function. A function of the type p of x upon q of x, where px and qx, both of them are polynomial function, then we can say that this y equal to p of x upon q of x is a rational function. Whenever such functions are given, then you have to do the partial fraction. So let us recall what is the rule to do the partial fraction. Since this p of x and q of x are the polynomial, we can talk about its degree. If the degree of p of x is smaller than degree of q of x, then we'll do a partial fraction. Now what do you mean by partial fraction? That also I can explain you. And if the degree of p of x is greater than or equal to degree of q of x, then you have to divide the p of x by q of x and convert into this form. We'll solve a certain example of both the type, and first of all let us see what do you mean by partial fraction and how we do the partial fraction. If the p of x is a polynomial and our situation is p of x upon q of x is there, if the degree of p of x is smaller than the degree of q of x, then I said that you have to do the partial fraction. Since q of x is a polynomial over r or c, if I can say, it can be factorized into its field. So suppose that it has so there will be case 1 in which all the linear fractions are there. So q of x is of a linear factor, like let's say it is of degree n, that is x minus alpha 1, x minus alpha 2 up to x minus alpha n. These are the linear fraction or factor of q. Then this p of x upon q of x you have to represent as a upon x minus alpha 1 plus b upon x minus alpha 2, or I can say a1, here it is a2 up to an upon x minus alpha n. The case 2, it may possible that few of the roots in this are equal. So in that case, suppose that this is the situation that x minus alpha 1 square is there, that means alpha 1 and alpha 2 are the same roots, but rest of them are the different roots, that is x minus alpha 3 up to so on x minus alpha n is there. If this is the situation, then you have to factorize your rational function as a upon x minus alpha 1 plus b upon x minus alpha 1 square plus that a3 upon x minus alpha 3 up to an upon x minus alpha n as it is. The case number 3, you will have, it may happen that there are instead of 2 roots there are n roots which are equal, or I can say rth roots are equal. Then your polynomial qx is of the form x minus alpha 1 raised to r, and the next term is alpha r plus 1 up to x minus x minus alpha n. In that case, this fraction, partial fraction, can be done in this manner: a upon x, or I can say a1 upon x minus alpha 1, a2 upon x minus alpha 2, sorry, alpha 1 square, up to ar upon x minus alpha r power r, and the rest, that is ar plus 1 upon x minus r alpha r plus 1 is as it is, and the last one is an upon x minus alpha n. So ultimately we have to calculate what is this a1, a2 up to alpha n. And the next case, that is the fourth case, it may possible that in the field of real numbers, it may possible that qx is not factorized into the linear fraction. It may possible that the qx is factorized into the quadratic factor like this: ax plus bx plus c. This cannot be factorized in the given field, and the rest of them is as it is. In that case, you have to factorize this rational function as a1x plus a2 upon ax square plus bx plus c, and the rest of them, it is a3 upon x minus alpha 3 up to so on an upon x minus alpha n. So these are the rules for the doing the partial fraction. Let us calculate and let us solve some of the examples to find out the nth derivative of a rational function. So the question is, if y is equal to x upon x plus 1, x plus 2, x plus 3, then find yn. So here you can see that this is the rational function px upon qx type. A degree of px, that we can say it is 1, and the degree of qx, that will be 3. That means the degree of the denominator is bigger, so we can able to do the partial fraction directly, and hence we can write down, we consider x upon x plus 1, x plus 2, x plus 3 equal to a upon x plus 1 plus b upon x plus 2 plus c upon x plus c. Because there are three linear factors are there, so we can write down in this fashion. And if you take the LCM as x plus 1, x plus 2, x plus 3 on this side, then this x plus 1 into x plus 2, x plus 3 is that cancel out, and the further simplification will gives you a into x plus 2 into x plus 3, b into x plus 1 into x plus 3, plus c into x plus 1 into x plus 2. The objective is to calculate the value of a, b and c. That can be done in two ways. Either you can substitute, this equation is true for any value of x. So you can substitute some particular values of x here and calculate what is the value of a, b and c. Another way is to simplify this, that means simplify this to brackets, product them here also and here also, and then you compare the coefficient both sides. That will lead to a three linear equation in terms of a, b, c, and you can solve them. You will have the value of a, b and c. Here I am doing the one of the way by putting the sum, substituting some values. So if I put x is equal to minus 1, you can put any value you like. But why I am putting x is equal to minus 1? Because x is equal to minus 1 is one of the root of this polynomial q. So what will happen if I put x is equal to minus 1 here? This term will become 0 and this term will become 0. So only this term is there. because x plus 1 is a factor. So if I put x is equal to minus 1 here, minus 1 plus 1 will gives you 0 this one and 0 this one. So we'll have minus 1 is equal to a into minus 1 plus 2 minus 1 plus 3, which will implies that a equal to, this will left to 1 and this will left to 2, so it will gives me 1 minus 1 by 2. Now the next we can put x is equal to minus 2. So if you put x is equal to minus 2, this term will become 0 and this term is become 0 because it has a factor x plus 2. So only the term quantity is left this. So it will gives me minus 2 equal to b into minus 2 plus 1 minus 2 plus 3, which I can simplify as minus 2 equal to b into, this will gives me minus 1 and this will gives me 1. So this is gives me b equal to 2. Now if I put x is equal to minus 3, because the one of the factor is x is equal to minus 3, or I can say x plus 3 is one of the factor. So if I put x is equal to minus 3, this quantity will become 0, this will also be 0. The quantity is left is this side, that is minus 3 equal to c into minus 3 plus 1 minus 3 plus 2. And if you simplify further, this will gives me minus 3 equal to c into minus 2 into minus 1. So this will gives me c equal to minus 3. So ultimately we got the value of a, which is minus 1 by 2, b which will be 2, and c is minus 3. Let us substitute that value into this expression. So y equal to x upon x plus 1, x plus 2, x plus 3 is there. That can be written as a upon x plus 1, but a, the value of a we have calculated is minus 1 by 2, x plus 1, plus b upon x plus 2, but the value of b is 2, so it is 2 upon x plus 2. The third value we have calculated, it is minus 3 upon x plus 3. This is the value of y. If you want that the yn, the nth derivative of this, you have to take, so taking nth derivative both sides, we get yn. So before that we have to recall what is the formula for nth derivative of the function 1 upon ax plus b. That we have derived in one of my previous video. That is, if y equal to 1 upon ax plus b, then yn is minus 1 raised to n factorial a power n upon ax plus b power n plus 1. Here if you compare, your a is 1, b is also 1. So the nth derivative of 1 upon ax plus b, and this 1 minus 1 upon n is constant, so I can take outside from the derivative, will gives me minus 1 raised to n factorial a, the value of a is 1, so it is 1 power 1 power anything will be 1, so it is 1 upon x plus 1 power n plus 1. The next one is 2 into minus 1 raised to n upon into n factorial upon x plus 2 power n plus 1. Again in the same formula, a is 1 here. In the third one, that is 3 constant, the nth derivative of ax plus b, a is 1 here, so it is minus 1 raised to n into n factorial upon x plus 3 power n plus 1. You can see that minus 1 raised to n into n factorial is common out from this, So the quantity left inside, it is minus 1 upon 2 into x plus 1 power n plus 1 plus 2 upon x plus 2 raised to n plus 1 plus 3 upon x plus 3 raised to n plus 2. This will be the nth derivative of y. So in the similar kind, any of such functions are given, or rational functions are given of the order px upon qx, where the denominator can be factorized into the linear factor, then I think so you are able to solve the nth derivative of such function. Now second type of example that I am taking is if y is equal to x square upon x plus 2 into 2x plus 3. Here what is the thing is, the numerator is of degree, that means the p of x as our notation, it is of degree 2, and the denominator is also of degree 2. And as per the rule of partial fraction, what I told you is that numerator, if the degree is less than the denominator, then we can do the partial fraction. Otherwise, we have to divide the two polynomials. So let us first simplify the denominator here. So as the denominator is x plus 2 into 2x plus 3, that can be multiplied together. That will be 2x square plus 3x plus 4x plus 6 will gives you 2x square plus 7x plus 6. So this is equal to x square upon 2x square plus 7x plus 6. And then we'll divide these two polynomials. That will leads to, so by multiplying this one, we'll write x square here and 2x square plus 7x plus 6 on this side. Since this is x square, I should multiply 1 by 2 here. So it will gives me x square plus 7 by 2x plus 3, and then I subtract this. This will get cancelled out, so we will have minus 7 by 2x minus 3. And this expression now I can rewrite as that x square into x plus 2 into 2x plus 3 can be written as minus 1 by 2. That minus 1 by 2 is a remainder, and then it is plus minus 7 by 2x minus 3 upon this quantity x plus 2, 2x plus 3. This is the quotient, 7 by 2x minus 3, minus 7 by 2x minus 3 is a quotient. So that can be written in this way. Now you can see this is my y, which I have expressed in this fashion. Now once we have divided this one, what will happen is now the denominator of the numerator is less than the denominator. So now we are able to take the partial fraction of this quantity. So to do the partial fraction of that one, I am just writing as in this fashion, that is x plus 2 into 2x plus 3, that is equal to a upon x plus 2 plus b upon 2x plus 3, because there are two linear factors are here. So that is 7 by 2x minus 3 is equal to a into 2x plus 3 plus b into x plus 2. Now if I substitute, now there are two ways as I told you to do this. Either you can multiply this brackets, simplify on this side, find out the coefficient of x and the constant term and compare. That will lead to two linear equations and solve them. Another way is to substituting the values. So let us do in another way here. So we can have some another method to do this. So therefore this is minus 7 by 2x minus 3 is equal to 2a plus b x plus 3a plus 2b. and comparing coefficient both side, we get 2a plus b is equal to minus 7 by 2. And 3a plus 3b is minus 3. Sorry, 3a plus 2b is minus 3. Now if you want to simplify these two things, you have to do some calculation, but I will write down what is the quantity that I got by finding the value of a and b. That is easy to calculate this two linear equation, and you can check that x square by x plus 2, 2x plus 3 can be represented now, because once you have the value of a and b, you substitute that value of a and b here, and then you substitute all this value here, and it is minus 1 by 2 that I am taking out, and you will left with minus 1 into 8 upon x plus 2 plus 9 2x plus 3. So this is the expression of this x square upon x plus 2 into 2x plus 3. This is my function y. Now taking the nth derivative both sides, we get, if you take the nth derivative, this is the first one is the constant term, and this constant term will have the derivative 0. Okay, so if you can say that, as you can see that the first derivative is 0, the next term is also 0. So this minus, sorry, here it should not be minus, it is a plus sign here. So this minus I have did by mistake. So please make it correction. So if you do this 1 by 2 multiply to this side, and if I take the nth derivative, then 8 is already there. 8 by 2 is the constant quantity that I can take out. So we'll have yn, which is minus 8 by 2. And then it is a derivative of 1 upon ax plus b. And we have the formula for y equal to 1 upon ax plus b. The nth derivative of this one is minus 1 raised to n into n factorial a power n upon ax plus b power n plus 1. As per this will gives me minus 1 raised to n into n factorial upon x plus 2 power n plus 1, because a is 1 and b is 2. Next it is 9, so it is 9 by 2, so plus 9 by 2, minus 1 raised to n upon n factorial, again by this formula, but here a is there, but a is here 2, so that's why it is 2 power n upon 2x plus 3 power n plus 1. So finally you can see that what will be the formula we have, or what will the expression you can get for nth derivative of the given function, that is minus 1 raised to n into n factorial is common out. This 2 is also common. You can write down this term here, that is 9 into 2 power n upon 2x plus 3 power n plus 1 minus 8 upon x plus 2 power n plus 1. This is the nth derivative of the given function. Let us discuss one more class of the function here. That means the next example is if y equal to x cube by x square minus 1 Then the question is find the value of find yn at 0. The question is to calculate what is yn at 0. Here you should note that the numerator is of a degree 3 and in the denominator is of degree 2. So you have to do the division. It is x cube x square minus 1. If I multiply x, this will become x cube, so it is x cube minus x. So if I divide that, sorry, I subtract this one, then you will have x here. So this expression, that is x cube upon x square minus 1, can be written as, this is a remainder, this is a remainder and this is a quotient, so it is x plus x upon x square minus 1. And this x square minus 1 can be factorized into two factors, that is x minus 1, x plus 1. Now ultimately we have to factorize this quantity, and to factorize this quantity we can write down as x minus 1, x plus 1. See, there is another way is to do this one. Obviously you can do as our previous two methods which I have explained you earlier. But you just, whenever it is a two linear factor is there, then you just write down x minus 1 and x plus 1 as it is on the numerator. Here your requirement to get x. So if I put plus sign or minus sign, that is depends on this x is cancelled out or it will remain. So if I put plus sign here, then x plus x will become 2x and this minus 1 and 1 will get cancelled. Since I need x here, so I just divide by 2 here. So it will, the expression or the simplification of this quantity will give me this. And then it is 1 by 2. If I divide, I'm making the partial fraction of this one, this will give me x plus 1 upon x minus 1. And if I substitute this value here, so my function y, that is x cube upon x square minus 1, will leads to x plus 1 by 2, 1 upon x plus 1 plus 1 by 2, 1 upon x minus 1. Now if I take the nth derivative both sides, but if I directly take the nth derivative, this will become 1 because the first derivative of x is 1. So I am taking the first derivative. So taking the derivative both sides, we get y1, which is 1 plus 1 by 2. The derivative of 1 upon x is, we know that it is minus 1 upon x square. So it is minus 1 upon x plus 1 whole square. This is minus 1 by 2, 1 upon x minus whole square. And this, if I call this is as equation 1, and I am taking the derivative of nth derivative of equation 1 with n is greater than 1. So the value of n should be greater than 1. We get, so it should be more than 1. Otherwise what will happen? The first derivative is there, the second derivative, you can say it is 0. So the n, so this n, the value of n is greater than 1. So y n we have, the derivative of this quantity will become 0. This is 1 by 2. The nth derivative of this 1 upon ax plus b, we know it is minus 1 raised to n upon into n factorial upon x plus 1 power n plus 1. Here a is 1, so that's 1 raised to n will become 1 plus 1 by 2 minus 1 raised to n into n factorial upon x minus 1 power n plus 1 if n is greater than 1. Now the next task is to calculate, actually the question was to calculate yn at 0. Here we got the yn. So what will happen if I put substituting the value and x is equal to 0 here? So the next one we get yn at 0, which will be 1 by 2 is common out. If I take also common out minus 1 raised to n into n factorial from this two terms. So the left quantity is 1 upon 0 plus 1 power n plus 1 plus 1 upon 0 minus 1 power n plus 1. So this will give me 1 by 2 into minus 1 raised to n into n factorial 1 plus minus 1 raised to n plus 1. This is yn at 0 if n is greater than 1, and y1 at 0 that we can get from this substituting 0 here, that is 1. This is also 1, and this is 1 by 2. This is minus 1 raised to 1, so this is also 1. So minus 1 by 2 minus 1 by 2 will become 1, and 1 minus 1 will become 0. So y1 at 0 is 0. So this is the terms we got for this. Let us solve couple of more examples. So if I have y is equal to x upon x square by a square, then this denominator is not factorized further into the linear factor. Then we will use some of the quantity from the complex factors. So this quantity I may write as, you know that in the complex factor, that is x minus ia, x plus ia. So what actually I did is I just write down this equation as minus x square minus I a square, as using the I square is minus 1. So the I square is minus 1, so it is minus minus become plus, so and the a square minus b square will leads to this. And this can be factorized into the manner as we have did earlier, that is by writing this x plus ia and x minus ia on the numerator as it is, and then putting the appropriate sign if you require. So here I need x, so if I put minus then x will destroy, so I should put plus here. So this minus ia will get cancelled and you will left with 2x on the numerator. So that's why I am just multiplying 2 here, dividing 2 here. So therefore now a y equal to 1 by 2, you will left with 1 upon x minus ia plus 1 upon x plus ia. So we can take the nth derivative. So taking the nth derivative, both sides, we get yn will be 1 by 2 is a constant, minus 1 raised to n factorial, a is 1 here, x minus ia power n plus 1 plus minus 1 raised to n into n factorial upon x plus ia power n plus 1. This is the nth derivative, but if you want to express this is further, then you can just take this x is equal to r cos theta and a equal to r sin theta. Because why we are doing this? Because this expression is given into the real number and the results come into the I, which is a complex number. So the yn should be a real quantity or real number, real quantity. So to get it is a real quantity, we are doing this by substituting r equal to x is equal to r cos theta and a equal to r sin theta. So we know that r is square root of x square plus a square, and theta will be tan inverse of a by x. So what will be this? X minus I into a power n plus 1. If I substitute this one here, we know it is 1 upon r cos theta and r sin theta. If substitute, r will get common out, so it is r power n plus 1 is common out. Here we'll have cos theta minus I sin theta power n plus 1. And as per the De Morgan's theorem, it says that cos theta plus I sin theta power n will be cos n theta plus I sin n theta. And if it is minus here, then it will be minus. So as per this will gives me 1 upon r raised to n plus 1. If I take this is in the numerator, then this is cos theta minus I sin theta raised to minus n plus 1. And using this, we can write down this is 1 upon r power n plus 1 cos of minus, and cos is an even function, so it is n plus 1 theta, because cos of minus theta will be cos theta and sine of minus theta will be minus sine theta. So that's why this is minus become plus I sine n plus 1 theta. So 1 upon x minus Ia is this. Similar manner, what will be 1 upon x minus x plus Ia power n plus 1. So if I substitute x is equal to r cos theta and a is equal to r sin theta, this is r power n plus 1. 1 over cos theta plus I sin theta power n plus 1. Again I can write down into the same manner n plus 1 cos theta plus I sin theta power minus of n plus 1. So this is 1 upon r power n plus 1 cos theta n plus 1 theta minus I sin n plus 1 theta. Due to this De Morgan's theorem and using the cos is an even function, sine is an odd function, we'll have this. If I call this is as a statement 2 and this one is statement 1, then adding this 1 and 2, or I can substituting the value of add 1 and 2, the yn which we have, which is represent as 1 by 2, this quantity plus this minus 1 raised to n plus into n factorial will get common. Minus 1 raised to n into n factorial is got common. This you can see that here it is 1 upon r power n and 1 upon r power n plus 1 is there, so it is get common. So you left with cos n plus 1 theta plus I sin n plus 1 theta. That is the first quantity, and the second quantity is this is the first one plus sign, and in between minus sign it is the second quantity, n plus 1 theta minus I sin n plus 1 theta, and this is get cancelled. So you will left with yn will be minus 1 raised to n into n factorial upon r raised to n plus 1 cos n plus 1 theta, where what is the value of r and theta? R is square root of x square plus a square and theta is tan inverse of a by x. Why we got this? Due to this 2 times cos and 2 is get cancelled, so that's why we got, and this is the final answer for nth derivative of 1 upon x square plus a square, sorry, x upon x square plus a square. Let us solve one more example and the last example for this video, that is y is equal to x log x minus 1 upon x plus 1. So the question is to calculate what is the nth derivative of this function. Here you can show that the function is not the rational function, it is a log is involved there, and it is not directly solved as per the known formula of the nth derivative. So what we can do is the idea is to calculate what is the first derivative of that. So according to the product rule for derivatives, the x, I can say it is as it is, a derivative of this quantity I can, if I want to derivative this one, I am using the log a upon b things, that is log a upon log b. So if I use this one, this log a upon b will be log a minus log b. If I use that one, we'll have this, and if I use the derivative formula, then the log of x minus 1 will be 1 upon x minus 1. The derivative of log of x plus 1 is log 1 upon x plus 1, plus a derivative of x is 1, and the log x minus 1 minus log x plus 1 will be as it is. Now this expression that I can write down as 2x upon x minus 1 x plus 1, because if you take the LCM on this, you can just see that the only 2 is left, and plus log x minus 1 x plus 1 is there, and then you have to factorize or do the partial fraction of this one, which you can do it as in the method which I told you, that they just write down the numerator, whatever the factors are in the denominator is given, and then you just put appropriate sign. So if I put plus sign here, 1 will get cancelled, so we are left with 2 plus log x minus 1 log x plus 1 is there, and then the y1 we have, it is 1 upon x plus 1 plus 1 upon x minus 1 plus log x minus 1 minus log x plus 1, and this, all of them are well known functions for the nth derivative, because we know that if y is equal to ax plus b, then the nth derivative is minus 1 raised to n factorial a power n upon ax plus b power n plus 1, and if y is equal to log ax plus b, then the ynth is ynth derivative of this one that we have obtained, it is minus 1 raised to n minus 1 factorial a power n upon ax plus b power n. Now I hope that you can able to find out what is the ynth derivative of this by using this two formula. That's it for this video. If you like this video, please press the like button. If you have any comment, suggestion or a question, please drop down in the comment box below. See you in next video. Till then, bye bye.